6/4 is just addition, subtraction, and multiplication of the things we've been talking about. So, of course, I'm not just saying, oh, we're just adding, subtracting, multiplying, dividing. We're just applying those things to radicals, okay? So if I have 7 square roots of 3 plus 6 square roots of 3, I want you to pause the video real quick, think for a second about how you would add these two, and then press play again to see the answer. So, maybe you were tempted to add the 6 and 7 and get 13, and add the 3 and the 3 and get the square root of 6. Okay? Or maybe you thought, well, 7 and 3 is 10, and 6 and 3 is 9, so it's like the square root of 19. Okay? While both of those are valid attempts, because this is inside the square root, we're going to treat it as if it was the variable x. We're saying there are 7 of these and 6 of the same thing. So if there's 7 of these and 6 of these, that's really 13 square roots of 3. So even though you might be tempted to add the insides, don't add the insides. Okay? Matter of fact, we can only do addition. Only add, subtract if we can only add and subtract if the inside is the, you guessed it, same. Okay, we can only add and subtract these kinds of pieces if the inside is the same. Okay, well, let's look at another example then. How about 6 square root of 5 minus 4 square root of 5? Okay, well, 6 minus 4, 2 square roots of 5. So once again, the inside piece was the same, so we can put them together. Okay, so let's do a few examples. Let's do a few examples of this and see what we can come up with. Okay, 4 square roots of 6 plus 5 square roots of 54. Okay, so we've run into a problem. The problem is that 54 and 6 are not the same. So how can we come up with a solution here? Why don't we try to see if 54 can be broken down into anything? So I'm going to take, just like I was doing a minute ago, 54 is 2 and 27, and then 3 and 9, and 9 is 3 and 3. Okay, so I have my 4 square roots of 6. Basically what I'm doing here is I'm applying 6.3 to 6.4. You thought you got away with simplifying, but it's back. Okay, so I still have the 5, but now I have 2, 3, 3, 3 inside. 2, 3, 3, 3. What kind of root is this? It's the square root. So if it's the square root, we're looking for groups of how many? Yeah, groups of 2. So I've got a group of 2 here. So I'm going to take that outside. So I have 4 square roots of 6 plus 5 times multiply. We're multiplying this times this. So when I pull something out, I'm still multiplying. So times 3 square root. What is 2 times 3? 6. Hey, do the inside pieces match now? They do. So now I can put all this stuff together. But what comes first? Addition or multiplication? Multiplication. So 4 square root of 6 plus 15 square root of 6. When I add those together, what do I get? 19 square roots of 6. Okay? So that's really it for addition and subtraction. All you have to do is make sure the insides are the same. Okay? Addition, subtraction, inside must be the same. Okay, now, for multiplication, this has been a really boring few weeks, I've watched all of Netflix, and I've played video games so much that I'm just bored of it. But hey, let's hope on the Zoom meetings that you guys will show up and ask questions so we can actually talk. Okay. Sorry, I'm done now. Multiplication. Multiplication is a little bit different. It always is slightly different. So if I have the same exact numbers that I started with at the beginning, 7 square root of 3 times 6 square root of 3. So before I was adding, and when we added, we got 13 square roots of 3. But when we multiply, it's a little different. We're multiplying the numbers first, then we're multiplying the insides second. Okay, 7 times 6. 7 times 6 is 42. Okay, now we have the square root of 3 times 3. Well, what's 3 times 3? That's 9. So we multiplied the numbers first, then we multiplied the inside pieces of the root second. So first numbers, second inside pieces of the root. Now, we're not done with this problem though, because what's the square root of 9? 3. So 42 times 3. Remember, this is a product. This is multiplication. This times the square root of that. 7 times the square root of 3. 6 times the square root of 3. It's all multiplication. So when I take that square root, I still have to multiply, which would be, they're supposed to tell me the answer. 3 times 2 is 6, 4 times 1, 26. 126. Okay, so let's do another example like this. How about the square root of 3 times x plus square root of 5? Okay, the square root of 3 times x plus the square root of 5. Okay, so now I've done it, right? Now I've gone and made it harder again, just like in math, we always do, right? We take something easy, we add a step, add a step, add a step. And so the step I've added is that now this thing has to be what? Distributed to both. So I gotta take this times the first. Well, what's x times anything? It's just x and that thing together. So x square root of 3. And then now, how do we multiply two square roots together? We multiply the outsides. Well, what's 1 times 1? 1. What's the insides? Square root of 3 times square root of 5? Square root of 15. Now, can we put these together? No, they're not the same. 3 and 15 are not the same. Will 15 break down into a pair of 3s? No, it can't. So are we done? Yes. And so that's something to be careful about. When I'm doing multiplication, it may break down into addition and subtraction, at which point I'll have to go back to those rules and do those things again. Okay, so sorry if I'm ever talking too fast. Just play the video on 0.75 speed. Yeah. Sorry. Okay. Now, what I'm gonna do is maybe like 3 more examples of multiplication. Let's see. Something one step above what we just did. 3 cube roots of 7 times 4x minus 2 cube roots of 2. Okay. Okay, so this one is a little bit more challenging, but remember, we still just do what? We still just distribute. So this times this, 3 cube root of 7 times 4x minus 3 cube root of 7. Well, I took the minus sign from there, so this has to be positive here. Okay. Now, 3 times 4, 12. And there's nothing to multiply by x, so x. And there's nothing for the root to multiply, so root of 7. Now, the next piece, we have negative 3 and 2, so that's negative 6. The cube root of 7 times the cube root of 2. What's 7 times 2? 14. And so we have our answer. So once again, don't let your brain go into overload mode where you're like, I see so many things all at once. Take a deep breath. Do the things that you know how to do step by step. We all know if we see something outside of parentheses, we can distribute it unless there's an exponent up here, right? Yeah. But most of the time we can distribute that thing. Okay? So I'm going to erase this, but I'm going to do one more example, except for this time I'm going to take it one step further. Okay? The red didn't erase very well, so, well, I'm dropping everything. Let's see. 4 cube root of 3 plus square root of 2. Oh, sorry, I said cube root. That's really square root. Square root of 3 minus 5 square root of 2. Okay, now, always remember the rules from the past. Just because this looks different doesn't mean that it behaves differently. Okay, so this is where we double distribution. The first thing times both. 4 cube root times, 4 square root of 3 times square root of 3. 4 square root of, plus 4 square root of 3 times negative 5 square root of 2. Okay, the first thing times both. That's always how we do double distribution. Now, we have to do the second piece. Boom, boom, like that. Yeah, same thing, just different pieces. So, plus square root of 2 times square root of 3 plus square root of 2 times negative 5 square root of 2. I'll put those. Now I can go back and do the pieces, do the actual math. Remember, I have gotten into a habit where I write down this step. Is it necessary? No, but is it sometimes helpful? Yes. So 4 times 1 is 4. Square root of 3 times square root of 3 is square root of 9. Okay, 4 times negative 5 is negative 20. Square root of 3 times square root of 2, square root of 6. So as you see here, I'm doing number times number, inside times inside. Number times number, inside times inside. Okay, I'm just always going to keep that pattern. Here, I distributed. Here, I'm following the rules for adding, subtracting, multiplying the radicals. Okay, so square root of 2 times the square root of 3, square root of 6. Square root of 2 times negative 5. Well, there's really a 1 here, so 1 times negative 5, negative 5. Square root of 2 times square root of 2 is square root of 4. Okay, now, just like always, we're looking for like terms. So the middle two are alike. So that gives me negative 19 square root of 6. Negative 20 plus 1, negative 19. Now, what's the square root of 9? 3. 3 times 4 12. So rewind that if you need it again. Negative 5. What's the square root of 4? 2. 2 times 5, 10. So do we have anything in common? Those two. 12 minus 10 is 2. And we are